Okay, to start with problem number 1. The voltage V across a capacitor at time t is given by this formula, where V equals 146.3 times 1 over 2.72 raised to the power of 0.41 times t. So our question is asking us, identify the voltage across the capacitor at 8 seconds, rounded to the nearest hundredth. So this one's pretty easy. We have our formula right here, and all we have to do is substitute 8 in for t. So here you can see V is equal to 146.3 times 1 over 2.72 times 41 times t, and 41 times t is equal to 3.28. So that's what we're going to do here, is we're going to have this formula raised to the power of 3.28. And if you was to get your calculator out and raise 1 over 2.72 to the power of 3.24 and multiply that by 146.3, you're going to come up with the answer of 5.49362. And in our question here, we're asked to raise it, round it to the nearest hundredth. So right there. So we're going to drop that, and we're going to be left with 5.49. And as we can see here, that is one of our questions, and that's the answer to number 1. Looking at problem 2 here, identify all the real, and this is an important part of this question, 8th roots of negative 256. So if we were to come up, let's try to take an 8th root of negative 256, the first thing we would have to do is take out an imaginary number for our negative here. But at the point that we take an imaginary number, or an I, it becomes a not real number. So the answer we're looking for here is no real 8th roots. But let's go ahead and work this one out to see what an answer would be if we were taking imaginary numbers. So if you was to take the I out of this, we'd be left with this problem, is I times the 8th root of positive 256. Now, if you were to factor this out into its smallest units, you would get 2 times 2 times 2 little technical problem there, but going ahead, times 2 times 2 times 2 times 2 times 2. Factor out to 8 2's. Now, much like a square root, if we were trying to move these outside of the radical, where we would pair them off in pairs of 2, with an 8th root, we're trying to pair them off in pairs of 8, which we have here, 1, 2, 3, 4, 5, 6, 7, 8. So if we were to take an 8th root, we would move 1, 2, so we'd reduce these all to 1, 2, and it'd be I. So our answer, if we were looking for an imaginary number, would be 2 times I. But for the purposes of this question, there are no real 8th roots.